All right, IBAISL2. Today we are continuing our work with derivatives. Today we're going to talk about marginal costs, tangents, and normals. So first up, we got to talk about this word marginal cost. Marginal cost is really only for word problems that involve money, like producing things for a certain cost. It's really just a secret code word for like the derivative function. So anytime you see this, you should think, I'm using the derivative to find the marginal cost. So they tell us the cost of producing motorcycle helmets can be modeled by this function right here. Only from 0 to 150, where X is the number of motorcycle helmets produced and C is the cost in US dollars. First up, part A, they say write down the cost of the company if no helmets are produced. Well, if no helmets are produced, that's putting in a 0 into the function. So we'll do C of 0, which is 600 plus 7 times 0 minus 0.00010 cubed, which is just $600 because the zeros get rid of this part and this part. So no derivatives yet. That was just the cost to produce no helmets. Part B, find an expression for the marginal cost. And they even tell you right here that that expression is C prime of X. That is just doing the power function to find the derivative of that function. So if C of X is 600 plus 7X minus 0.0001 X cubed, if we're going to take the derivative of this, remember the derivative of a number is just 0, so that part goes away. And then the derivative of 7x is just 7. So here we'll start to build this derivative. It's 7, and then you have to do a power rule for this guy. You got to bring it out in front and multiply it with the 0.0001, which gives us 0.0003 x squared when you drop the power down one. So this is the marginal cost expression. Part C, find the marginal cost of producing 20 helmets and 80 helmets. So the first part, we'll do C prime of 20. So C prime of 20, when you plug it into this equation, you get 7 minus 0.0003 times 20 squared, which is 6.88. For part 2, you're going to put in 80 into the derivative, which is 7, take away 0.0003, 80 squared, which is 5.08. Now, what these mean is, well, I guess this is part D. Each of those are the cost per helmet to make that many helmets. So this is in dollars, cost per helmet. So the interpretation on this guy right here is that to make 20 helmets, each one will cost $6.88. And then if you make 80 helmets, each one is going to cost about $5. So notice that the cost keeps going down the more you make. And that's up to 150 helmets. Second one. A hammock can be modeled by f of x equals 2x squared plus 3x minus 4. A mosquito traveling in a straight line of gradient 11 touches the hammock at point A. Find the coordinates of point A. This is the most hilarious word problem I've ever seen. It's like, is this an application? This is not real world math. Come on. Just give us the function and say you want us to find the point where the slope of 11 touches the thing. So whatever. Okay. You guys, because it says gradient of 11, remember the gradient is the slope and the derivative is the slope machine. So first step, we're going to take that derivative. If you do a power rule on this right here, the 2 will come out in front and be multiplied, and then the derivative of 3x is just 3, and then this part will completely just go away. And I'm going to need that equation later, so I'm going to get rid of these. So the derivative is 4x plus 3. Then it says a mosquito traveling in a straight line has a gradient of 11, and we need to figure out when it touches point A. You guys, the gradient is 11. This is a slope machine that you put in x's and you get out slopes, aka gradients. So what we need to do is set 11 equal to 4x plus 3, because we need to figure out what x value produces a slope of 11 or gradient of 11. Subtract 3 from both sides. Divide by 4, you get x is equal to 2. Now, that's the x coordinate where it touches point A, but they want the actual coordinates of point A. So, to find the coordinates, you need to put it back into the coordinate machine. So, for coordinates, you need to use the original machine. So, just like the derivative is a slope machine, I think of the original as a coordinate machine. So we are going to take x equals 2 and put it into that function. So f of 2 is 2 times 2 squared plus 3 times 2 take away 4, which if you simplify that is 10. So f of 2 is equal to 10. So that means the mosquito is going to touch the hammock at the coordinate 2, 10. Amazing word problem, just so relatable. Next one. This was another ridiculous word problem. It was about like that function is the side of a hill, model for a side of a hill, and then there's a monastery at the top of the hill, which could be a great tourist attraction. So it's decided they're going to build a funicular railway to reach the top of the hill, but then it was like basically just a tangent problem. So I stripped the problem down so we don't have to carve our way through all of the word problem. Okay, you guys, here's the deal. If we're going to find the equation of a tangent, the equation of a tangent is a y equals mx plus b. The m is going to come from the slope. The m is the slope, and it's going to come from the slope machine, aka the derivative. So first step with any of these problems is find the derivative. So you're going to do your power rule where the 2 comes out in front, and then the derivative of 3.4x is just 3.4. So our derivative, f prime of x, is negative 0.04x. Because the 2 comes out and multiplies with the 0.02, and then you drop the power down 1, plus 3.4. Then, next step is you're going to plug in x value to find slope, which slope is going to be the m in the y equals mx plus b. So, next step, f prime of 50. So we need to do negative 0.04 times 50 plus 3.4, which I think is 1.4. Now, that is the slope in the y equals mx plus b. We know it's slope because it came out of the slope machine. Derivatives are slope machines. So right now, we know our equation is y equals 1.4x plus b. Now, to find the b value, we have to have a coordinate to be able to plug into that, but we don't really have a coordinate right now. So, step 3, and this is the one that people struggle with. We're going to plug the x equals 50 into the original function to be able to find the coordinate that the tangent touches on the curve. So this right here, this is your coordinate machine. So what we're going to do is do f of 50, which is negative 0.02 50 squared plus 3.4 times 50. Now, when you plug that in to your calculator, you should get 120. So what this means is that the tangent touches the curve at 50, 120. Now, we're going to take that coordinate because that is also the coordinate that the tangent touches. So we need to plug that into the tangent to be able to figure out what the b value is. So step 4. Oh no, I'm running out of room. We're going to plug that back into the y equals mx plus b to be able to find out what the b value is. So we get 120 equals 1.4 times 50 plus b. And when you solve for b, you get 50. So final answer, equation of the tangent. Y equals slope, which we found from the slope machine, plus the y-intercept, which we found by plugging in the coordinate that it touches. Here's the entire problem, so you can see it all. Next up, I'm going to teach you guys how to find the equation of a normal. So before we get to that, we have to know what a normal is. So if you have some sort of curve, and it doesn't have to be a circle, it can be any type of curve, the tangent is the line that barely touches the curve at one spot, at this coordinate right here. A normal is sort of like the opposite of a tangent, where it still touches the same curve, or in the same spot, but it touches at a 90-degree angle. So it touches at a 90 degrees to the tangent. So this is the normal curve. Or normal line, sorry. Remember that perpendicular slopes, so the normal and the tangent are perpendicular to each other. Perpendicular slopes are negative reciprocals of each other. For example, if the slope of one is 3/7, then the other one is negative 7/3. They're upside down negative versions of each other. So to be able to find the equation of the normal to this curve at the point where x equals 1, first step is we're going to find our slope machine. Use your power rule, pop and drop, you get 6x squared plus 3. Then we're going to plug in 1 into the slope machine to figure out what the slope of the tangent would be, which is 9. Now, that 9 is the slope of the tangent, but we want the slope of the normal. So that means the normal slope is the negative reciprocal. It's negative 1 over 9. So far, our normal curve is negative 1/9 x plus b. Now, we don't know the b value, but we need to plug in a coordinate. And then how are we going to find a coordinate? Well, it's the same way we did in that last problem. We're going to plug in 1 into the coordinate machine to figure out what point it touches. So we'll need f of 1, which is 2 times 1 cubed plus 3 times 1, take away 2, which is 2 plus 3 plus or minus 2, so that's 3, I think. Yeah. So f of 1 is 3, which means the coordinate that the normal touches is 1, 3. So then we're going to take this and plug it into this guy right here. So we get 3 is equal to negative 1/9 plus b. So 3 plus 1/9 is equal to b. 27/9 plus 1/9 is 28/9. So the equation of the normal is y equals negative 1/9 x plus 28/9. There's the whole problem. Okay, there is one more example, but I feel like this video is getting a little long, so perhaps we'll do this one as a warm-up or during class, or I'll tack it on to the next video. But this is a good challenge problem for you to try. All right, guys, ask me questions in class, please.